Yeah, sorry about that. So much gas. Yeah. It's not like anybody's watching anyways, but who knows? What am I looking for? I am looking for a YouTube control panel document. Thank you. Crap. Oh well. Okay. Anyways, alright, so we're back to doing Dead Simple Python. We're on to chapter 4 now. And let's see what's going on here. And chapter 4 is page 73. Structuring a Python project. Okay. Be aware you're skipping over the setup.config file or the setup.py file. He'll cover it in chapter 18. Okay. Setting up a repository. I haven't really learned how to figure that out yet. That'll be another day. Modules and packages. You can leave the empty as it so often is. Okay, and then we're going to the PEP 8. We're on page 75. Where articles, posts, and Stack Overflow claiming that since Python 3 you no longer need the init file. The initialize file in packages is completely false. Namespace packages are very specific edge cases that cannot replace traditional packages. In my structure, omission is a package that contains other packages, thus omission is my top level package, and all other packages underneath are sub packages. Okay, so let's get started at the bottom here. So we have so we need to we're gonna change directory to chapter 4, and inside chapter 4 we are going to make a directory called omission git. And then inside omission git we are coding license.md, and then we are going to we're just going to save this. I don't know what we're putting in here. And then in here we're going to make directory omission. Yeah, I'm gonna clear all this so it cleans it up a bit. Okay. And then we're gonna code init dunder. Oh, we're not in that. Whoops. Yeah, we're gonna change directory. Oh, balls. I'm too lazy for this. Drag, drop. Yes. Okay. And now I have to change directory to omission git, and then we have to change directory to omission, and then we can code dunder init dunder dot py. And we'll hit the save. Go back in here. Code space dunder dot py. Enter. Save. And then we need to code. Whoop. And then we need to code app.py. And then we need to once again hit the save button, tab over, watch the cat flop around, and then we need to make directory common clear. There, we'll make it a little bit bigger for no one. And then we're going to change we're going to change directory to common, and we have to code init.py. My goodness, this is a lot of stuff to set up, but I'm sure he has a reason. Okay, and then we're back up one level to make a directory called data. And clear, and then we need to change directory to data or data, whatever. This is already annoying. And I'm already thinking about, like, just creating a Python script that just starts taking in files and folder names. Just to deal with this. I need to hit the save button. I need to get back to here. I need to rename this. scoreboard.py. Save. Code. Settings.py. Whoop. Settings.py. Save. Now we're back over to here. And then we need to change directory by going up one. Then we need to make a directory. We're going to call it interface clear. Then we're going to make another directory, and it's just called game. And then we're going to change directory to game. And then inside the game, we're going to hit up a bunch of times. Oh, fuck. I fucked up spelling on every single one of them. Didn't I? No, just this one. Okay, while we're in the game, we're doing code test game item .py that was a test. Fuck me. Yeah. Content loader.py. Code game item.py. I can see how getting this all set up and sitting down in the beginning just takes forever as someone who has to do project management on construction sites for construction projects. It is getting things set up takes the most amount of time, and people don't appreciate it at all because it takes so much time. And if everything is set up in advance, you can if you get everything done in advance, it's just so much easier. So what do we got? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. Okay, now we're back over to here, and we're gonna change directory, go up one level into omission, and then we're making one called resources. And then we're making another directory called tests. We're going to change directory to tests. Hit the clear. Yes, I do. Okay, and now that I'm in here, code. Game round settings. Save. Back over. Code. Test. Scoreboard. This seems like it's going to be fun. Because we'll be creating an entire game. And I guess that would be really fun to do as a job, which is just testing everything out and trying to break it. We're going to test our tests. And code. Just hit don't save. Code test underscore timer dot py, and now we'll hit the save. Okay. Okay, and now we gotta back out of that. Back out of that. Now we're back into a mission. We're back into a mission git. So I bought this book from Chapters Indigo, and it says it lays flat my ass. I have it attached to another book with a binder, like a binding clip, in order to have the one side stay open. And I don't know what that is. What did it make, though? It didn't seem to make anything. Oh, yeah, we'll hit the save. I don't know what that is. And then readme.md that nobody ever reads. And then we're doing another code.get ignore. Okay. Well, that seemed to get everything. Okay. So we're back all the way to this. We're finally finished all that. Jesus Christ, it took forever. You'll see that I have one top-level package called a mission with 4 sub-packages. Tests each sub-package contain an init file. Every file on that ends in a py module. I also have resources, but it only contains game audio. Omitted here for brevity. Resources directory, not a regular package, does not contain. I have another special file on my top-level package called main. Yep. Oh. Wait. Huh. Interesting. Oh, no. I was right. That's right. It's just going down by folder first. So yeah, I'm looking at this whole thing. Yeah. 1, 2, 3, 4. There should be one called license. There isn't one called license. Oh, that's because it's in chapter 4. Oh. Okay. Because I put it in the wrong spot. Yeah, there we go. Okay, so I have a folder called omission git, and then I have license. Huh. Okay, so I have license in a folder called omission, and then omission.py, a pylint, and git ignore. Yep. And then inside omission, I have an app.py, correct. I have an init and a main, correct. And then inside of common, I'm looking at the, I don't know, this is going to be silly, but I'm looking through the Windows thing. File Explorer. Init, class properties, enums. I'm just double checking everything is there, because if it's not, then I don't want to have to go back. Settings, scoreboard, game round, data loader, py. Okay. And the game. Oh, wait. Yeah, we have an interface with nothing in it. We have game with init, content loader, game item, game round, and a timer. Yes. Resources is empty, and then tests, init, game item, round settings, scoreboard, test, and timer. Okay, yeah, we're good. Okay, so we now have all that in place. Okay. Yeah, how import works. Yeah, once you've imported the module, you can access any variables or functions or classes defined within it. When you import the module, you're actually running it, which in turn executes any other import statements from the module. If there are any errors or performance costs in those secondarily and onward imported modules, they might seem to originate from your otherwise innocent import statement. That means that Python is able to find all of those modules. For example, the module repy, which is part of the Python standard library, has several important statements of its own, which are executed when you import .re. contents of those imported modules aren't automatically available to the file you import RE from, but those modules have to exist for import RE to succeed. If for some unlikely reason enum.py, another module that's part of the Python standard library, got deleted from your Python environment and you ran RE, it would fall with an error. Module error not found. No name. Okay. This might seem confusing error message. I've seen people erroneously wonder why the outer module, this example RE, couldn't be found. Others take note that this scenario is fictional. Import enum and import will never fail under normal circumstances because most modules are part of the standard library. However, this little example demonstrates the common problem of import statements failing due to missing modules. Yeah. There are various ways of importing, but most of them should rarely, if ever, be used. For upcoming examples, I'll be using the module called Smart Door, which reads as follows. Okay, well, let's... Okay. Close that, close that, close that. Okay. So let's back it up here. We're in chapter 4, and then we're just going to do, we're going to make a directory called general. And then we're going to change directory to general, just so I can follow along here. We're going to hit code smart_door.py. We're going to hit the save button, and now we're going to start. I don't know why it's doing that. We're going to define open we're just going to print reminds me of it reminds me of the Hitchhiker's Guide to the Galaxy, where they have moved doors. Okay, we're gonna hit save real quick. Okay. Let's say I want to use this module in another Python file, which is in this example. It has to be in the same directory. To run the functions defined in this module, I would first have to import the module SmartDoor. The easiest way is bit. Okay, so let's go over to here, and then we're going to start a new one called use smartdoor.py. We're going to hit the save button so it starts saving. Oh, right. Shit. I changed the way that things work because I kept hitting... Hello. Hello, little one. Whoops. Okay, little one. What are we going to do now here? What are we doing here? You're blocking half the screen. What am I going to do? What are we going to do about that, huh? Huh? Is there something that we can do about that? Well, we can literally use the second screen because you're not blocking that one. So we'll be using OBS to figure this shit out. Okay, and then if we do Python dot that wasn't helpful. We're gonna hit, yeah, we gotta do use smart door. And we hit that. Thank you for using the simple door. Thank you. Yes, yes, you are a very cute kitty. Yes. The namespace above encloses a smart door. The namespace is an explicitly identified path, something such as a function. Okay. Namespaces are one honking great idea. Let's do more of those. Okay. Okay, yeah, where they are and they aren't coming from. So yeah, I know that it's coming from a module called Smart Door, and inside the module Smart Door there is a function called open and a function called closed. Okay. Be advised, referring to namespaces, I'm not necessarily talking about the explicit namespace package, which I do not cover in this book. There are some bad examples. Namespaces. Importing functions. In my previous function calls, I referred to. Yeah. Okay. So, then what it is saying is we can close this off. So now, so yeah, it still has to be in the same. Close that off real quick. I don't know what the fuck. Where's my computer going fucking crazy? And then we can go from smart. Oh. From smart door import the name of the function itself, and then all we got to do is just hit open. If we hit save, we come back over to here, we hit up, use smart door. Well, but on the open, this doesn't say what that. When you have multiple lines of code, this doesn't say where it's coming from. I guess the next question is, can you just hit smart door.open and still get the same effect? No. Okay. The only reason why I asked this is that I don't want to load all of Smart Door, because what if Smart Door had, like, let's say Smart Door was like 5 megs big, like, let's just say it's huge, and I don't want it to load. I don't want it to load it. I just want it to load like one, like from math. I just want to import math, one thing from math. All right. Okay, so then yeah, I would have to do something like smart door underscore open delete is equal to open and then print smart door. Actually, I don't even need to go that far. I don't even need to say F. Print smart door, and then come back over to here, and now I can hit use this. Oh, why did it do none? Oh, no. Wait, what? Yeah, okay, I didn't, the print function was already there. I didn't need to do anything about it. So yeah, that's how you would get it to there, but that's just a lot of extra steps. Okay, so you might have noticed another problem. Open is already built into Python function. Assume I need to read a file called data.txt, which exists in my current directory. If I try this after importing open from the smart door, my program is going to behave very badly. Some file equals open data.txt.read, working with file, close. When I used open earlier, I wanted to use smartdoor.open. Now the same file I'm trying to call Python built-in open function to open a text file for reading. Fortunately, because the earlier import built-in open function has been shadowed by smartdoor.open, meaning the presence of the later is making it impossible for Python to even find the former. This code will fail. Yep, okay. I got an error because I was trying to use the built-in open function, which accepts 2 arguments, but I unintentionally called smart door. Getting an actual error message is one of the better failure scenarios for this sort of mistake. It did accept 2 arguments. Depending on my code, it might wind up an error elsewhere. Yeah, okay. Oh. Okay, thankfully Python offers one as a keyword, which allows me to create an alias for the function. Oh, interesting. Imagine that. Like, I just keep reading along and I have my problem solved. So I could go from smart door. Fucking fingers. Import open, and I gotta from smart door import open. Yeah, no, it import open as door open from smart door import close. I do believe closes is its own method though, but whatever. then we can do door open and then close. We hit the save, hit the clear, hit up, and then for making a door very happy. Okay, yeah, we got there. Okay, and then what? In the import, I use a keyword to rename to door under open, but only in the context of this file. I can refer. Okay, this leaves Python built-in open function unshadowed, so earlier code working in the file can function properly. Trouble with nested packages. As you've seen, contains other packages. In my emission package, if I wanted to import the module dataloader.py, I could use this line to refer back. Okay, so yeah, import omission.data from. So import folder, file. This is a good structure all as well. At a certain point, however, nesting packages can become a pain. A function like music app.player.data.library.song.play is just ugly, and not to mention difficult to read. Some nesting of packages is certainly okay, but when your project starts looking like an elaborate set of Martoreshka dolls, I'm assuming that he's talking about like the nesting dolls, you've done something wrong. Organize your modules into packages, but keep the structure reasonably simple. Nesting 2 or 3 package deep is okay. Deeper is generally not advised. It's not advisable if it can be avoided. Although we never have overly nested nightmares in an ideal world, real life projects aren't always that neat. Sometimes it's possible to avoid deep nesting structures. I need another way to keep my import statements. Graciously, the import system can handle this. I only have to deal with the deeply nested namespace once. After that, I just used a function called play. Alternatively, if I wanted to save a bit of namespace, I can do that too. Just go one back. Yeah. My import statement has resolved in all last bit of namespace. Before long, you'll probably find yourself tempted to import all hundreds of functions in your module to save time. At this point, many developers go off the rails. This statement imports nearly everything in the module directly except for anything preceded by one or more underscores. This import all pattern is a very bad idea, as you won't know what all is getting imported or what will be shadowed in the process. The problem gets even worse when you start importing from multiple modules. Nope. All exists and fighting over the same name in your file. Function.gzip.open will win out in this example because this is the last version of open that was imported. Yeah. Left to right, top to bottom. Since no one is likely to remember every single function class, you can easily wind up with a lot of mess. Xenopython applies. Explicit is better than implicit. In the face of ambiguity, refuse temptation to guess. You should never have to guess where a function or a variable is coming from. There should be code somewhere in the file that explicitly tells you where everything comes from, and as seen in preceding examples. This import star doesn't quite work the same way the packages by default, and a line like from packages and import will be functionally the same as import some package, unless the package has been configured to work with importing within your project. Now that you know the structure of the project, you import. Recall my omission project. Here's a subsection of that project directory. Yeah, any one of these modules. Okay, because I I have a class called game mode defined within game enums.py module, which lives in the common package. I want to use this class within my game round setting module defined by omission. How do I get to it? Because I defined omission as a top level package and organized my modules into sub packages, it's pretty straightforward. In the game rounds setting, you type in from omission dot common dot game enums.py. Import game mode. Okay, that'll work. There's nothing there because I haven't even created it yet. Okay. One second. Okay, and that's the absolute import, and then we can do relative import. You can also import a module from the same package or subpackage known as a relative import or intra-packing. In practice, intra-packing references are easy to do wrong if some developer wanted to import game mode, which is provided by omission game enums into omission game data round settings. They might incorrectly use something like from common dot game enums import. No, that's not right. This fails, leaving the developer wondering why it doesn't work. The data package, where games has no knowledge of the siblings. So data doesn't know about siblings, so it needs to go back to its parent to find its sibling. Okay. Yep. Within omissions, I can use the following import statement. So I'm already in game round settings, so it could module knows what package it belongs to. Because of this, relative imports can start search for from the current package and move up and down through the project structure. Yeah, it says from dot dot common, which is change directory, dot dot is up one level. That would work. Yeah. Two dots mean current package, parent directory package, in this case omission. There is some difference of opinion among Python developers about whether to use absolute or relative. Personally, I prefer to use absolute whenever possible because I feel like it makes the code a lot more readable. You can make up your own mind. The only important factor is that the result should be obvious. There should be no mystery about where anything comes from. Yeah, I mean, I have no skin in the game. It would be based on whatever because I would be coming into something, it would be whatever the company says to do it. So that would just be the way that it is. Importing from the same package. There's another lurking gotcha here. In omission settings.py, I have this statement for importing And then in omission game round settings, so in the statement, omission data settings, he is saying from omission dot data dot game round settings import game round settings. I haven't even set up these things yet, but however, that will not work. It will fail to locate game round settings because I'm running a top level package. The absolute imports for anything within the package. I can instead use a relative import, which looks much simpler than absolute. In this case, the single dot means this package. This probably feels similar if you're using typical Unix file system. Yeah, one dot means current package. Okay, so what? So in order to I like the whole thing so I can follow it. I don't think it really makes that much of a difference, but keep in mind that levels are aren't just plain directories, they're packages. If you have two distinct packages in a plain directory that isn't a package, you can use relative imports to jump from one to another. Entry points. So far you've learned how to create modules, package projects, and how to make a full use of the import system. Last piece of the puzzle is gaining the ability to control what happens when a package is imported or executed, and the parts of the project that are run first when importing or executing are called entry points. Okay, when you import a Python module or package, it is given a special variable called _name. This contains a fully qualified name in the module, which import. For example, the fully qualified name of the module would be omission.period, common period game enums. There is one exception: when a module or package runs its name and its value is set to main. To demonstrate this, I assume I have a package called testpk, which contains the module awesome.py. It defines a function greet. Okay, at the bottom of the sum file. Oh, okay. So yeah. So if you're taking the CS50 as well as I am, or have taken it same as me, then it's talking about the last thing, I think. To demonstrate this, okay. At the bottom of the same file contains message print awesome module was run. In another module in the same directory as testpk, I have this module example.py. Okay, I have a package, which he's calling a package is also known as a folder. What is this py? I have no idea what this is. I have no idea what this is. Reveal in File Explorer. We're just going to send this to hit the delete key on that. I don't know what that is. We're going to go back to the general. We're in general, and we are going to make a directory called test pkg. I'm going to change directory to test pkg. 1 second. then we have a module, which is also another word for a file, called code.awesome.py. And inside awesome.py, we have define greet print hello world. Let's save. Okay, at the bottom of the same file, we're going to have print awesome file was run. Perfect. Okay, and then another file in the same directory, we are going to have another thing called example.py. Inside of example.py, we're going to say from test pk import awesome, and then we're going to say print name, and then what it's supposed to do is supposed to prints main, and then we're going to tell it to print awesome.name, and then that is going to print test pkg dot awesome. Okay, well let's see what it does. We shall clear this, and then we're gonna go Python example.py. We gotta go back over to here real quick, hit that save button, reopen this, and then run that. Okay. Oh. So this has to, we'll shove this into the directory, and now we'll try this again. Can't find it, so we're gonna go cd one step up. Prints it backwards. Oh yeah. Prints exactly what it's supposed to do. Well, look at the name, local variable name is presented. You signed it. Yep, the first line is coming from. Yeah. Okay, so this is where it's talking about like the CS50 if name is equal to main thing. Yeah. Okay. First line is common testing. If awesome.py is executed directly, name will have a value of main. Yeah, package entry point, so I might have main in the top level package. This file is automatically run when a package is executed directly, but never when importing the package. So inside this guy here, we can close this, 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 and this. So inside here, we need to define main, which will be all my code in here, and I don't want these errors showing up, so we'll just hit the ellipses, and then if name is equal and just run main. Yeah. Okay. I wonder. I'm not going to deal with that right now. I'm not going to deal with the JSON to, like, if I were to wanted to add this to every single thing, like, it has to be, every time that I open up a Python file, it needs to have the same thing, so. Okay. All the logic starting from the package belongs to the main function. If the if statement checks the name assigned to the main, since this package is being executed directly, the value of name is main. Code if statement being called to the main function is run. Otherwise, if main.py were only being imported, its fully qualified name would include its containing package, for example, omission dunder main. The condition would fail and the code wouldn't run. Controlling the package imports. The package init py file can come in handy when you want to change what is available for import and how it can be used. Most common uses for this file are to simplify imports to control the behavior of import all. Okay, so simplify imports. Imagine I have a particularly complicated package, rockets, which is made up of dozens of sub-packages and hundreds of modules. I can safely assume that many developers using the package won't want to know about most of the functionality. They only want one thing: to define a rocket and then launch it. Instead of expecting all users of my package to know where those few basic bits of functionality exist in the package structure, I can use dunder initialize to expose said functionality directly, making it bits easier to import later. Okay, I don't know if that's part of this thing that we're creating. It appears so. Okay. Maybe. Sure, let's just add it, and then we can always remove it. So we go back to not this one. We're talking this one, because this is the imports one, right? So we're doing from. Oh, we don't have anything about rockets. Okay, so yeah. Okay, so then, yeah, we'll have to go back to... Again, I don't know why this is here. Why this SciCast keeps popping up. But I can only assume that it does for some sort of reason. We'll go to general. Oops. So we're back to here. Oh, we're already in general. Okay. And then we shall make a directory called rockets. And then we're going to change directory to rockets. We're gonna clear, and then we're gonna code dunder init dunder dot py. Let's spell it correctly because you can already see that I did not. But we all have to do that afterwards. From dot small rocket dot rocket import small rocket, and then from large rocket import large rocket, then from launchpad dot pad import launchpad. Okay, we're gonna hit save. Come back over here. We're gonna rename this. Okay. Greatly simplifies the use of the package. I no longer need to remember things like small rocket and launch classes live in the rockets package structure. I can import them directly from top level package and use them. So, and then what it is saying, we do another code rocket usage .py. Let's spell correctly, please. Rocket usage .py. Okay, and then from rockets import small rocket. From rocket import small rocket, comma launch pad and pad is going to equal launch pad small rocket pad launch really simple, isn't it? Still nothing is actually preventing me from importing these things from a long form such as rocket import small. Shortcut is there, but it is optional. Because simplicity is such an essential part of Python philosophy, it is also an essential component of package design. If you can anticipate the most common ways the user might interact with your package, you can greatly simplify their code by adding a few lines to the init.py. By default, import all doesn't work with the package. If you use init.py enabled and control the behavior of import all, even though such an import statement is generally discouraged, this can be done by assigning a list of strings to dunder all, with each string containing something such as a package or module to import from the current package. This works well for the previous trick. Okay. So we're back to here to rockets So we could... the other option is to go yeah, so you just turned it into a list. When Python encounters a line from import, okay. When Python encounters a line like from rockets import asterisk, that list from all is seen as rockets. Dunder all is unpacked in place of the asterisk. This is important in figuring out what you can include in all. Each item in my list should make sense when substituted for an asterisk from rockets. In other words, I could change the last line of my init, and there would be no error in the code. This works because, as you already know, the line from rockets import small rocket is a valid import statement. On the other hand, this would not work. Yes. It fails because rockets from import small rockets does not make sense. You will have to consider this principle when defining dunder all. If dunder all is not defined in init.py, then from rockets.import will behave the same as import rockets. Okay. Right, so on my init, I can determine, in my initialize, I can determine what is included in import import regex or math or whatever, and they don't need to see any additional things that I have done, just the original. Like math has like multiplication, subtraction, and subtraction. They don't need to see how many times I did the addition to quote unquote multiply, or any of the other variables that I have. Okay. Alright. Program entry points. If you've applied all the concepts in this chapter to your project structure, you can run. However, you or your eventual end user may want to run the program merely by double-clicking and directly executing on a single Python file. With everything else in place, it is trivial to implement. To make my omission project easy to run, I'll create a single script file outside the top-level package named omission.py. Okay, so we can close all this. Okay, close general. Okay. Oh. Oh. Okay. Huh. Alright. Alright, so we're in chapter 4. We're going to change directory and we're going to go to mission -git. And then in here, huh. Interesting. How do I... Okay, so yeah, I just hit code omission.py and it just opened up the file. Okay, and then it's going to say from mission main import main. Okay. Better ways to create a program entry point, but I'll cover that. I'll cover those in chapter 18 once I've created the all-important setup config file. Again, what you have so far will be enough for development. Okay. Module structure path, or import path, defines where Python looks for packages and modules and what order it searches in. When you first start the Python, the module search path is assembled in order from the module Python path and a default path. You can view the search path with the following commands. Okay. Okay. Okay, so okay, so we'll save this. We'll go into here, mission.git, and then we'll just say we'll just give it a code system path.py. We're gonna import sys print sys.path. I hit save. Come back over here. Python system path.py. Oh my goodness, lots of stuff. Okay. Yeah, users, Jeremy documents, code with Jeremy, books, dead simple. Yeah. Program files. Okay. Yeah, makes sense. Okay. Because these are appended to the module search path, this technique cannot be used to replace any packages. Sorry, wait, what? The import system looks through each of the locations in the module search path in order. As soon as it finds a match for the module or package being imported, it stops. You can see here it searches the directory that I am running, standard libraries, and then everything installed with pip in a virtual environment. Okay, if you need to add locations to the module search path, the best way to use the virtual environment and the file, a file ending with path to directory package. The name of the file doesn't matter as long as the extension is path. For example, consider the following. Home and then okay. Each line must contain exactly one path to be appended. The absolute path will be appended to the module search path. Because these are appended to the module search path, this technique cannot be used to replace any packages or modules installed in the system or virtual environment. However, any new modules or packages in my bunch of code or awesome sauce directories will be available for import. It is possible to modify the variable syspath or your system's Python path variable, but you also shouldn't be doing this directly. Not only is it an indicator you've probably handled imports wrong, but it can also break stuff outside of your project. In this regard, syspath is the worst offender. If someone imports a module where you modify the syspath, it will mangle their module search path. Okay. Let's really look under the hood. Most of the time these details won't matter, but every now and then, such as when the wrong module seems to be imported in the service, it never hurts to know what's going on. Import statements calls the built-in import function. If you ever want to manually perform an import, use the import library module instead of calling import. To import a module, Python uses two special objects, a finder and a loader. In some cases, it uses an importer object which serves as both a finder and a loader. If the finder is responsible for locating the module to be imported, there are many places to look for modules. There aren't even necessary files. Built-in importer finds and loads built-in. Frozen importer finds, loads frozen modules, meaning the modules have been converted to compiled bytecode. Path-based finder looks in the file system for the module. This search order is the reason why you cannot globally shadow a built-in module, and built-in importer runs before the path-based finder. If you need some additional meta path finder, such as if you're importing a module from a novel location not already supported, you can add it as a meta hook by appending it to the sysmeta path link. There's some additional complexity to the path-based finder that is worth breaking down. The path-based finder tries each of the path entry finders in turn. The path, also known as path entry hooks, are stored in the sys.path hooks. Each one searches every location known as a path entry. The import path as specified by syspath or by path absolute current package. If there are any finder locates in the module, it returns module spec object with all information about how to load the module. However, if the meta path finders return none, you will get a module none found error. Jesus Christ, what the fuck? The finder is responsible for locating the module being imported. There are many places to look for modules. They aren't even necessarily finders. Number of special situations that must be handled. Okay, well that's actually the end of the chapter, everybody. Thanks for listening.